Good morning, everybody. Hello. Welcome to the Ice Worlds Festival. Welcome to the series of talks that we're doing as part of that. My name's Ed. I'm just the host, so you won't have to listen to me for much longer. But there's just a few little things. We have a great speaker lined up for you, and we'll be meeting her in just a second. We've also got time during this talk for a bit of a Q&A session. So we really do want to hear from you. We want to quiz our speaker. Try not to make things incredibly difficult. Or maybe a real exam. But during that, because we're also going out to YouTube, I'm going to come to you and I will repeat the question, which always seems a bit strange, but I will repeat the question so it definitely gets picked up and everybody can hear it. I think that's pretty much it, apart from to say that I also want to encourage everybody to go and, if you haven't already, check out all the British Antarctic Survey exhibits that we've got, not just on the Great Map, but we've got them in the learning spaces as well. Please do check those things out and go and take a look at the Sir David Attenborough on the river. I hope, well, maybe you haven't noticed, there's the big ship in the river, right, everybody? Okay, we'll go and check that out. And also, I'm going to put a call around also for on Saturday. We've got the Penguin Parade, so if you want to dress up like a penguin, there is an official reason to do that now as well. So, you know, but you can do it as well if you want, just off the top of your... Well, anyway, I'm waffling. Now, bear with me. I'm going to introduce the speaker, but I'm going to do a bit of reading because I want to make sure I get this correct. Because I keep referring to you as our speaker. But I do that because I'm saying you've been very generous and very patient with my terrible pronunciation. But our speaker today, okay, bear with, is Dr. Amelie Kirchgaessner. Okay, it's all right. That's my fault. But Amelie is an atmospheric scientist at the British Antarctic Survey, part of the atmospheric ice and climate team specifically, with a research focus on meteorology. And what we're going to be learning about today is about how to do that and how to be a polar scientist. So, well, take it away, Emily.
Thank you very much for the introduction and welcome to all of you. Yes, my name is Amelie Kirchgaessner, and I am by training a meteorologist and a physicist and climate scientist and polar scientist. I'm also a runner and a knitter. But today I'm going to tell you about my life as a polar scientist. During the last year and a half, this is what it looked like to be a polar scientist for me. I was working at home, but I'm not going to bore you a lot with what it was like in my home office, apart from I've got a moral support penguin in my home office. But I'm now going to go through some of the field experiments that I've been through over the number of years. And first we go back to 2005 in spring, where I was part of the field campaign going to the northern Norway. We were investigating what cyclones or low pressure systems, why they form in that area, preferably, a lot of them form in that area, and we wanted to know why, and we wanted to know what happens around their formation. I was for that experiment on this research ship, the Irish research ship Celtic Explorer. Colleagues of mine at the same time were flying on the Falcon, a German aircraft, research aircraft. We had a lot of instruments on the ship that measured humidity, measured temperature, wind speed, wind direction. We were launching radio songs or weather balloons around the clock, basically, every few hours. And we were also deploying little buoys that you will see later onto the water, and they would then also measure temperature and humidity and would transmit that back to us on the ship via satellite. And all of that together gives us sort of information what happens in these low pressure systems. You see there, that's what they look like on a satellite image, so very swirly patterns of clouds, and they're very windy and very moist. So a quick tour about around what work looked like on the ship. On the top, you see what our office looked like on the Celtic Explorer. So everything had to be tied down most of the time for rocking and rolling, and you had to make it as possible, as comfortable as you could with boxes to sit on. This is me launching one of the many radio songs on a good day from board, and this here at the bottom is one of the buoys that I mentioned earlier. My colleague on the left at the bottom is throwing the whole thing overboard, and then it expands, and then this little thing drifts away into the distance, taking measurements as it does so, and transmits them back to the ship, where we then could see what the position of that little buoy was and the temperature and conditions at that point. And that looks all very nice and fairly civilized. But we were there to study low pressure systems, so most of the time the water in the sea actually looked like that. And launching weather balloons didn't look like that. So like you saw on the other photo earlier, but it looked like that. So we were tied to the railing because the crew was afraid that we would get washed overboard. And as you see here, the balloon doesn't go straight up, but goes horizontally. And so we were watching it and saying, go up, go up, go up, go up. And eventually it actually did go up, but some actually did on the water, and we had to repeat the whole procedure of filling the balloon and everything and try again. So, so these are the stormy times. But when it was calm and nice and clear, we could see the aurora of the northern lights. So that made up for the rocking and rolling on the ship. We fast forward now a few years to another campaign that I've been on, now in the Antarctic. We worked as of northern Norway, the Arctic, and now we go to the Antarctic. You see on the map there on the top left, the Antarctic continent. And this project and these field experiments look like how do the mountains influence what happens on either side of them. So because what we see is that it's a lot warmer, maybe I should go on that side, on your right-hand side of the mountains than it is on the left-hand side of the mountains. And we wanted to know why that is and try and find an explanation for that. The idea behind it is that air, as it comes towards the mountain and rises, it cools, and the moisture in the air condensates. Some of you might have already heard about condensation in the learning space. And what happens then is that the moisture, when it has condensated, it falls out of the air as snow, and when the air then moves further and descends on the other side of the mountains, it warms up again, and it's drier and therefore warms a lot more than the moist air. And to prove the point, we use an automatic weather station, and this is now data from after 1 year. And you see at the top temperature, and you see all through the year we have these periods of very high temperature and at the same time very low humidity. And that's exactly what I mentioned earlier. We're looking for these events where it's very dry and very warm. And we found them. Again, a short business tour, what working for this looked like. This was my office in the research station at Rotorua. This was on your left side of the mountains. Well, at the same time, colleagues of mine were living like that. On the other side of the mountains, where there isn't a research station, So they had to live in a camp there for some time. They were doing similar things that we did. They were launching balloons, they were taking measurements. And the weather station that I mentioned earlier, this is what it looks like when you put a weather station into the field in Antarctica. You get on a plane, you pack everything up, you fly somewhere where probably no one has ever been before. You get out, you look around, you think, whoa. And then you go build a weather station, put it up, you go make sure it's got power, there's solar power, so you bring a solar panel with them and plug it all together. And then you get back on the plane and fly back to the station. And keep your fingers crossed that the data transmission works back. And fortunately, that all worked very well. And that's why I could show you the graph on the previous slide with the data. This was from that field campaign, probably my favorite photo, which is just one that I took late at night, walking back from my office to the block of the building where we were staying. And it's of landscapes like that you also see when you're a polar scientist. You go there and you imagine, you experience these beautiful, beautiful landscapes with the iceberg in the bay. For the next field campaign that I'm talking with you through is we went a bit further south to the station at Halle, so on the Antarctic continent, and that was looking at clouds in Antarctica. What are they made of? Are they made of droplets? Are they made out of ice crystals? How many of these droplets and ice crystals are there? How big are these particles? And what are the particles that the droplets and the ice crystals form on? Where do these particles come from? And we investigated that at Halle, iconic station that you might have seen before, and particularly the ground-based measurements we took in this lab on the bottom here, which you can actually see at the distance, maybe, this tiny spot. It's 1 kilometer away from the actual base in a clear air area, so you don't want any air pollution in that area, and that's why if you want to get there, you have to go by ski or walk there. So that was our commute when we wanted to work in that lab. You put the skis on and walk along there. We also complemented the measurements on the ground in the lab with aircraft measurements. This is our aircraft that we used for this campaign. And on the left here, you see an inlet here on the aircraft, where we sample aerosols, so these tiny particles that are in the air. The probes on the top underneath the wings, here and there. They tell you about whether if you fly through clouds, whether you will fly through droplets or ice crystals, and they take photos and go through the images, so they also tell you something about the size of these droplets, about how much water there is in these clouds. But they are quite interesting. And at the bottom here, underneath the nose, it's the cloud droplet probe, and that just basically counts how many cloud droplets you catch off while you fly along. Again, the different workstations on the top left, that was what it looked like inside the station when you had a bit of office desk there. On the top bottom left, that's me in the clean air laboratory working with a bag of air samples. On the right here, you see focus of what it looks like when you're in the aircraft and when you monitor what the instruments all feed into. It all comes together there, and you can see what's happening, and You see some of the ice crystals on the top right there. Sometimes you have to switch power on and heating on, so the influence goes these up. Go back. What it looks like inside the research aircraft when you fly on that. On the last day of that campaign, we were lucky enough to go to a nearby penguin colony. So this is a penguin colony. It was December, so summer, and there were lots of penguin chicks there. They still have their gown, gray gown feathers, and soon after they would have changed into the waterproof normal feathers that they need to swim and dive and actually hunt for food. At the moment they are not waterproof, so they need to stay on land. For the last tour, was the most recent one, we go back to the Arctic. In 2019-20, I took part in Mosaic, which was the multidisciplinary drifting observatory for the study of the Arctic climate. It's a big international campaign all around the German icebreaker, the Polarstern. And the Polarstern was frozen into the Arctic sea ice for 1 year. I was lucky enough to be there at the beginning when we left from Sø and went into the sea ice and checked a lot of the instruments up. We see in this cartoon how many different disciplines work together. We had oceanographers, we had glaciologists looking at the ice, we had biologists looking at the ecosystem underneath the water and in the ice. And we were all working together to understand what is happening in the Arctic climate ecosystem and how these components work together and how they react to the change that we're seeing. Here on the top, you see on the map the cruise track where we went from Norway into the ice, then the drift pattern with the ice, and then eventually Polarstern came back to Bremerhaven after a long, long time. In this case, my workspace looked like a shipping container, which we initially used to get all our equipment from Cambridge onto the ship in Norway. And then while we were going north, I converted it into a lab. And we've got filter sampling systems there. We've got particle counters through inlets in the roof. We've got an aerosol mass spectrometer there. And even a little bit of gas space and lots of other equipment stored away everywhere. One of the instruments that you've seen earlier on the aircraft was now on the crow's nest. So part of my commute was going up and down a ladder here to get to that instrument when I needed to go there. And last but not least, of course, we were working on the sea ice. We had on the top right so-called rocket snaps that can collect the blowing snow, so we can measure or get an idea of how much snow is actually lifted up by winds and displaced by winds. And on the left here is doing installation and McMath with a lot of temperature, wind speed, wind direction, humidity, the usual thing. But on top of that, we also complemented that with snow particle counters here at the bottom. Again, that help us distinguish between snow that is falling normally and snow that is lifted up by the wind, because we had them at 2 levels. And with that lovely polar bear cup, I'm coming to an end. This was a cup that came with its mother almost daily through the ship while we were setting up. Then we had to drop everything, go back to the ship, be safe, and wait for the polar bear to disappear again. And they were really scientifically very interested. They were sort of investigating everything, and a huge privilege to watch. And I think with that, I'm handing over to you for questions.
All right. Well, first of all, can we say thank you very much to the speaker? That was great. Certainly a very unusual set of office environments and a nice commute sometimes. Folks, we have a little bit of time for some questions. Does anyone have anything they want to ask? Your hand's been... Do you have something? I'll come and then we can repeat it. Yeah? Okay. Oh, you've forgotten the question. Well, that's all right. Well, maybe we'll come back to you. Don't worry. Oh, we'll come down the front here. Ah, yes. So what was the lowest temperature you've ever worked in? Because actually, I noticed that you were talking about high temperatures at one point, and they seem to be barely above zero. So what's low for you, and what's the lowest?
The lowest I've personally been into was probably minus 25 degrees. And at the same time, it was quite windy, so it felt even colder. But yeah, but it's cold for me.
I think that's pretty cold for everybody. Yeah.
The weather balloons, the meteorological balloons, how high up would they go, and how long do they stay up for?
Good question. Yes. How high up do the weather balloons go, and how long do they last for?
They go. They can go up to 25 kilometers. And it can, it depends on the ascent rate, how fast they go up. Depends on how much helium you fill them with, because you have some control over that, and you want it to go at a steady rate. And it takes about 2 hours, let's say, to go that way, and then the balloon expands further and further, and eventually explodes, and then the whole thing drops. And depending on where that happens, you get geyser while the balloon goes up, and geyser while the balloon drops very quickly again. Or not the balloon, but the radio song underneath it.
What was the seed that first took you into this sort of work?
Okay, so sorry if I can just repeat, just because we've got people listening home. So it's a good question though, what is the seed that gets you into this work, or got you specifically into this work?
I was early on, I like weather, and I like experiencing weather and storms and being out in the elements. And I also was quite interested in physics and of how things work, how nature works on a physical level. And so meteorology seemed the obvious way into that. And I studied at Hamburg in the university, and they have a long tradition of working in the polar regions. So I did my diploma thesis in a group already that was involved in polar work. I was surrounded by people who work in polar regions. One of my colleagues at university went to winter in Antarctica. Another one went, while I still was at university, he went on a cruise with the Polarstern to the Arctic. So I was surrounded by people who did these amazing things and went to these amazing places. And I thought, oh, well, obviously that's something you can do. Yeah.
Any other questions? Do we have anyone on this side? Yes.
Just asking about what's both poles, what's the difference? Working in north and south? Or?
Good set of questions there. So you've been both north and south. Which do you prefer? What's the difference between them?
They are really quite different. I mean, not least because the Antarctic is a continent surrounded by ocean, and the Arctic is of a mostly frozen ocean. In the Arctic, in some ways, depending on where you are, you get more wildlife. You see birds, you can see walrus and polar bears, if you're lucky, and they are not too close. You have that experience, while particularly when you're very far south on the Antarctic continent, it's flat, it's very barren, there's no wildlife. It's a very different environment. I'm not sure, they both have their fascination in their own way. Yeah, I'm very glad that I got the chance and the opportunity to experience both of them. And of course, they have to go south to see penguins. So.
We've got this young man here, I think.
What was your first impression when you saw the wildlife?
What was your first impression when you saw the wildlife?
I was just completely overwhelmed and just go, wow. So actually, we didn't see that much wildlife on my first cruise to the Arctic. So the most amazing thing was my first penguin that I saw. And I just almost couldn't believe it. I was walking along, and suddenly there was this penguin in the wild, and it was just there. And they're not shy, they just stand there, and we are told to keep our distance. And sometimes you have to step away because they come towards you. You know, it's not that we need to, not get any closer. We need to make sure that they don't get any closer to us. Yeah.
Got this young man in the middle of the row. What's that?
Did you ever meet any indigenous people in your expeditions?
That's a good question. Do you meet any indigenous people?
I didn't meet any. I worked mostly on working on leaving from Svalbard, which is basically part of Norway and has as such no indigenous population. I haven't worked in the Canadian Arctic yet, but I worked I'd be very interested to tap into their knowledge because that's something that we haven't done enough in the past. And yeah, and kind of the whole way of life, I think, is also very interesting anyway, apart from what we can get scientifically out of that.
Okay, I think we've got time for one last question, so I'm going to give it to this young man here.
When you saw, like, polar bears, or if you saw, did any of the wildlife scare you a bit?
So did any of the wildlife scare you?
Well, you see, when we were working in the Arctic, and we were checking up things on the sea ice, and we were concentrating, and we had fortunately a polar bear guard, so someone who does nothing but looking around and looking out for polar bears. And they suddenly get, guys, there's a polar bear and it's coming our way. You need to stop working now and get ready to go back to the ship. Polar bears can be very fast. So it is really quite clever to do what you're told and not drop everything, but, don't hang around, make sure everything's safe and you get back to the ship. It's where they live and we don't have the right to be there. It's of a privilege and we need to work with them and make sure that we don't interfere with them. So if they come, we have to step back and go.
Excellent.
Yeah.
Folks, first of all, can we have another round of applause for Speaker Amelie? That was absolutely brilliant. Really good. I'm afraid we are out of time for this talk, but having said that, Amelie's out on the exhibits outside in the learning spaces. So
exactly, I'm in the learning space. If you want to grab me and ask more questions or learn more about clouds and sea ice, come and see me and my colleagues there.
Absolutely. And of course, this is just one of our series of talks. So we've got another one coming up at the start of the hour again. We're doing them throughout the day and we're doing them tomorrow as well. Please make sure you go and take a look at the ship and the exhibits. And as I say, dress as penguins if you want to. Why not? But thank you so much for coming, everybody. And we hope to see you again. Thank you.